So we're going to be doing some long division today, and then some synthetic division. Synthetic division is easier than long division. I'll go ahead and tell you that. You'll realize that pretty quickly. But long division is going to be necessary for something we're going to do later on. We're going to use synthetic division quite a bit as we deal with higher degree polynomials. But when we get to rational functions, then the long division comes back. So it's a skill we need to start working on now. So long division is where we're going to start because it's the one that takes probably the most amount of time. So I'm going to start with that one. So we're going to be doing long division like we did in elementary school, where you maybe took a number 4 and divided it into a larger number, like 1,047, something like that. I remember doing that. Okay, so you looked at that number out here and you said, okay, does 4 go into 1? And it doesn't. Okay, so then you said, okay, well, does 4 go into 10? How many times? 2. That gets it closest to 10. So we would put a 2 up here. And then how did we get what went under here? We multiplied 2 times 4 and then did subtraction. So we got 8, and then we subtracted that, and that was 2. And then we brought down the 4. Right? Remember doing that? And then 4 goes into 24. How many times? 6 times. 6 times 4 is 24. And again, we're going to subtract 0 there, and we bring down the 7. How many times does 4 go into 7? Once. And then 1 times 4 is 4. And we subtract again. And there's 3. Does 4 go into 3? No. Okay. Now, at one point in your mathematical careers, you said, okay, 4 doesn't go into 3. So then you did R3. I remember seeing that at some point. After you did that for a little while, maybe 3rd grade, 4th grade, you started putting a decimal point and kept going with your division. Okay. What we're going to be working on is this remainder idea with polynomials. Because polynomials, once you get here, you can't really go any further, so you're going to have a remainder out of that. So we're going to be using the remainder idea with this. And when you're dealing with polynomials, if you've got 2 polynomials, we'll call one of them a of x divided by b of x. When you divide those 2, you get what's this q of x equal, or excuse me, not equals, plus r of x over b of x. All right, I'm going to explain what each of these pieces are. So this is a polynomial division algorithm is really what it's called. But it really doesn't matter about that. When you divide, what's the answer to any division problem called? Remember that word? A quotient. Q of x is the quotient for this polynomial division. Okay, so for our problem that we just did, the quotient is that number up on top there. The 261 is the quotient. R of x here for the polynomial is the remainder. That remainder may have some letters in it. It may not. Depends on the problem. Okay, that's going to change with every problem. Okay, but the remainder, when we're dealing with polynomials, can be written over what you divided by, what's called the divisor. The dividend is the number up top, or what we're dividing into, dividend in. That's the way I always remember that. And the divisor is what we're dividing by. Okay, but we're going to get a quotient and we're going to get a remainder. That's our goals for this. There are certain things that happen when the remainder is 0, and that's where we're headed later on next week, actually. So there's some things that happen when that remainder is 0 that make things nice. But we're going to look at some long division and then do some synthetic division. So let's start with long division. We're going to take 3x squared plus 22x plus 30. And we're going to divide that by x plus 6. Okay. Writing out a division problem there. If I'm going to do long division, I'm going to put it in the long division kind of style of doing things. So I'm going to put x plus 6 on the outside. And then underneath that weird symbol thing, 3x squared plus 22x plus 30. There are some important things to remember when you're setting up your division, whether we're using long division or synthetic. So these are important things to remember about setup. Okay, so I'll put over here setup. I'm going to put a box there. Important things about setup. Make sure it's descending order. Okay, that's one important thing. Make sure both of them are in descending order, not just the stuff on the inside, but the stuff on the outside too. Make sure it's in descending order. As you're making sure it's in descending order, you also want to have a representative for every smaller power. Okay, these are the only two important things about setup. Okay, descending order, and then have a representative for every smaller power. Okay, so that means once I put it in descending order, I've got the largest exponent first on the inside of the division symbol and on the outside. I want to have a representative for every one. If there is a piece missing, you need to put a 0 and then whatever, x squared. If there, here we start with x squared. If this problem did not have 22x in it, if it was just 3x squared plus 30, you would need to put a 0x squared in there, or 0x in there to make sure you had a representative from each smaller power. We'll do one or two that's got some missing pieces in it, but these are the important things. Every time you're doing setup for either long division or synthetic, you want to make sure these things. Okay, we'll do some examples where that stuff happens. Okay, now long division with polynomials is a lot like long division with numbers, except for you don't think in terms of goes into. You think in terms of times what gets me this. Okay, so when I look at this, I say, okay, there's an x plus 6. It would be very, very difficult for us to think about x plus 6 all together and see what would get this. So we want to make it easier on ourselves. So the method that you want to use is you look at this number or this term, the first term in your divisor, what you're dividing by, and it's x. What times x will get me 3x squared? 3x, okay? That's what we're going to put up here, is a 3x. So I'm going to put a 3x right there. Notice that I put it up above the x term in my polynomial, okay? Just keeping things lined up column by column, okay? Now, when we did the long division problem at the beginning with the numbers, what did we do after we wrote that number up here? We times it times the divisor, right? Up there we said 2 times 4 and wrote the 8 down and did subtraction. So here we're going to multiply 3x times this little binomial here. So what property are we going to have to use? Exterior property. Why did we do multiplication with polynomials first? You need it. Okay? 3 times x is 3x squared. 3 times plus 6 would be plus 18x. Okay. Up here in our number problem, we then subtracted that, right? The difference is with polynomials, you're not just subtracting one piece, you're subtracting all of that. Okay? So put it in parentheses, put the minus sign out in the front. Why did we do a subtraction of polynomials before we did division of polynomials? Because we got to subtract polynomials to divide them. Okay? So 3x squared minus 3x squared. What happens to those? Cancel out. That's what we want to happen. That should happen every time. If you're doing it right, that first piece should always cancel out. Okay? So those go away. And then we have 22x minus 18x. 4x. So we get this number up here by saying what times x gets me this piece. So that's where 3x came from. 3x times x is 3x squared. 3x times 6 is 18x. Then we subtract all of that from the polynomial above it. Okay. Once we got here, when we were doing our number problem, what did we do next? We dropped down the next piece, right? The next number. Well, the next piece here is a plus 30. So I'm going to drop down plus 30 right there. Okay. Just like I did with the numbers. I'm dropping that next piece down. Y'all?
The 3x squared plus 18x. No, it's 3x squared minus 18x. Just add 18.
Yeah, it's going to be the double negative there. Yeah, you're always going to kind of distribute that negative sign across is what's happening there. But you're always going to subtract at that step. Okay. Now we go back to here. What times x will give me 4x? 4. What kind of 4? Positive 4. So if it's a positive 4, up top we're going to put plus 4, right? Notice how that's over the plain number. Things are lining up. Okay. What do we do next? Multiply that times all of this out in front. So 4 times x is 4x. That's what we want. 4 times positive 6, positive 24, plus 24. Again, we parentheses and subtract. The 4x is canceled. That should happen every time, okay? All right. 30 minus 24, 6. Now, is there anything times x that'll give me plain 6? No. That's how I know this is my remainder. Because I can't multiply x times something and get rid of the x. Okay? It's always going to, if I multiply something times x, I get an x on it. Okay? This is my remainder. Okay? 3x plus 4 plus 6 over x plus 6. This is the quotient. That 6 that's up top is the remainder. In terms of polynomial stuff, this is q of x. That's r of x. That 6 is the remainder function, even though it's just plain 6.
Why do we have that x plus 6 in there?
Because that's our divisor. One of the other ways of doing that, instead of writing r, because we're dealing with polynomials, you don't want to write r6 like that because it's a polynomial. You want to use that when you were doing long division with numbers. You actually, this could also be written as 261 and 3/4, like a mixed number idea that you could do it that way. That's the same thing. 261 and 3/4 is actually 261 plus 3/4 in long notation. The shorthand notation is just make a mixed number out of it. But that's really what a mixed number means. With polynomials, you just don't want to put r this because it is a polynomial out of that. And our main objectives today are recognize the quotient, recognize the remainder. Okay, and then we're going to build off of that later on. Okay, so there's an example of long division with that. Okay, let's do another one. One's not enough, obviously. I know. Okay, so let's take one that's maybe a little bit bigger. 3x cubed minus 6x plus 13 divided by 3x squared minus 3x minus 6. See if we can get somewhere with this one. So we're going to do long division here. I'll go ahead and tell you, this one you would have to do long division on because your divisor is not linear. It's got an exponent on the x. Anytime your divisor has an exponent on the x, you've got to do long division. You don't have an option. The first example we can actually do with synthetic division, and I'll show you how to do that in a little bit. But if the divisor has an exponent bigger than 1, then you have to do long division. There's no synthetic division for that. All right, so let's set this one up. So we got 3x squared minus 3x minus 6 on the outside. On the inside, you got 3x cubed. Then what? Remember, what are our important things? Descending order, which they're in, and also we have to have a representative from where? Every power of x that's smaller. We're starting with x cubed, so we've got to have somebody for x squared. There's not one, so we put plus 0x squared, and then a minus 6x and a plus 13. Got to put that 0x squared in there so that we've got a representative from every smaller power. Now, start at the beginning. Front term. What times 3x squared would get me 3x cubed? It's plain old x, 1x, right? I'm just going to put it over the... I like to keep things lined up. You may see people that don't line it up like that, and it's technically correct, but I like to keep things lined up just because it keeps you organized. You know where you're at. Okay? So now what do we do with this x here? Distribute it to everything in the divisor in the front. So x times 3x squared, 3x cubed, x times negative 3x, negative 3x squared, x times negative 6, negative 6x. Parentheses, subtract. All right. What happens to the x cubes? They go away. If those don't go away, something's not right. Okay. Your job is to make those go away. If you're not getting those to cancel out, you're not got the right number up here. Okay. 0 minus negative 3x squared. Yeah, positive 3x squared. Okay. Negative 6 minus negative 6. Okay. Those cancel out. So that's technically plus 0x. Okay. I'm putting that in there, remember, because I still need a representative from every power. Even though those canceled out, and we made these cancel out, but this right here, we need that because I know the next step is to drop this down, right? So I'm dropping the plus 13 down. It's going to work out kind of nice. What do we do next? Go back to the front. What times this 3x squared gets me 3x squared? 1. Kind of 1. Positive 1. So up top, we put a plus 1. Notice that the plus 1 is over the plain number. That's lines things up, makes things organized. It works better if it's that way. Okay. What do we do with that plus 1? Distribute it to the divisor, what we're dividing by. Okay. 1 times, so it's just 3x squared minus 3x minus 6. 1 times all that's the same thing. Don't forget, parentheses, subtract. Okay. What happens to the 3x squareds? They cancel out. 0x minus negative 3x. Positive 3x. 13 minus negative 6. Plus 18 or 19. Right? Okay.
Oh, wait, never mind.
You okay? All right. Now, here's how we know we're done. That this is the remainder. Look at the power here. It's squared. There's nothing I can multiply times x squared that's going to knock it down a power, right? Because if I multiply times anything, it's going to at least have an x squared on it. So I know because this is smaller than my divisor that this is the remainder. So the remainder for this one happened to have an x in it. So it really is more of a function than the 6 is on the first example. So when we write our answer, the quotient is x plus 1. The remainder is 3x plus 19. And then we're always going to write that over the top of 3x squared minus 3x minus 6. Again, this is the quotient. This is the remainder. Remember those things, okay? It's important to remember. It's not that bad. It's a process that you've got to, if you mess up, there's a lot of places because you're doing, you count how many operations we've done here. There's a place just writing the problem down that you could have messed up. If you don't have that there, you're going to be missing a piece, and it gets confusing when that piece is missing out of that. So we did 1, 2, 3, 4, 5, 6, 7 operations, 8, 9, 10, 11, 12, 13 operations to do that. So there's 13 places that you could have made a mistake. There's a lot of places that you can make mistakes. But if you just take your time, breathe while you're doing it, it's going to work out for you. Let's look at this one. 7x to the 4th minus 8x cubed plus 16x squared plus 30 divided by x squared minus 2x plus 3. Okay. We can do long division with this one, and then we'll try to dive into synthetic division, which is much shorter. Yay. All right. Set it up. What goes on the outside? Yeah. Is everything there on the outside? Do we need to add anything to it? No. We got x squared. We got a plain x. We got a plain number. So everything is there. We don't have to add anything to the outside. We always want to check that as we're setting up. For the inside, we got 7x to the 4th minus 8x cubed plus 16x squared. Now what? 0x. And then a plus 30. Remember, we've got to have that representative from every power, from the biggest to the smallest. Okay? It did not have a plain x, so we got to put that in there. Okay? That'll help us keep everything lined up and work out good for us. All right. This one might be a little bit bigger, but again, process is the same. Start at the beginning. 1 times x squared gives me 7x to the 4th. 7x squared. I'm going to put that over the top of the x squared stuff. That's where that goes, guys. The 0 came from the fact that there was not a plain x in there. We have to have a representative from all of the smaller powers. We started with 4th, so we know we got to have an x cubed. If there's not one, we're going to replace it with a 0 there. So anytime there's one missing, that'll help you keep lined up and everything, and so you'll have something to subtract from later on. Okay. What do we do with the 7x squared? Distribute it to the divisor. So that'd be 7x to the 4th minus 14x cubed plus 21x squared. Parentheses and subtract. A lot of folks want to leave out the parentheses, and most of those folks make the mistake of not subtracting everything. They subtract the first piece and then add the others. That's incorrect. All right, so what happens to the 7x to the fourths? Go away. Negative 8x cubed minus negative 14x cubed. Six x cubed, positive 6x cubed. So negative 8 minus a negative turns that into plus 14. So that'd be positive 6x cubed. And then we have 16x squared minus 21x squared. Negative 5x squared. Drop down the 0x. Even though it's 0, drop it down. So we're going to need it in the next step. What's the next step for this? What times that gives me this? 6x. Positive 6x or negative 6x? Positive. Then distribute. And, parentheses, subtract. Big subtraction. X cubes cancel out. That's what we want to happen. And then we have negative 5 minus negative 12. 7x squared. And then 0 minus 18. Negative 18x. And then we're going to drop down the 30. Is this the remainder? Why not? It's still x squared, so it's not smaller than this yet. So we know we can go another step. Right? So how many times will x squared go into, or what times x squared gives me 7x squared? 7. So it's just a plus 7 on the end there. That's going to give us 7x squared minus 14x plus 21. Parentheses and subtract. X squareds go away. Negative 18 minus negative 14. Negative 4x. 30 minus 21. Plus 9. Is that the remainder? Yes. It's smaller than what we're divided by, so we know that's the remainder. Okay? So, 7x squared plus 6x plus 7 plus negative 4x plus 9 over what we divided by, x squared minus 2x plus 3. This part is the quotient. This part is the remainder. Okay. The way we write it polynomial style is this, like that. All right. Long division, fun stuff. Let's talk about synthetic division. Synthetic division takes the letters out of it. Makes it a little easier because you don't have to deal with x squareds and x cubes and all that stuff, okay? But synthetic can only be used if the divisor is linear. No exponent. Okay, that's the only time we can use synthetic. Okay. Which is going to be handy. We're going to have a lot of cases where we're dividing by a linear piece. If we're dividing by anything that has an x squared or an x cubed or anything bigger than that, then we have to use long division. Synthetic division works really great when we have linear divisors. Okay, and Those would be binomials type things, okay? So let's look at an example of how to do that. So I'm going to show you the setup and all that stuff. Setup rules are still the same, though. Got to be descending order, got to fill in the empty spots with zeros, okay? All of those rules still apply as far as division setup goes. All right, so let's take this one, for example. 2x cubed minus 19x plus 8 divided by x minus 3. And we're going to do that with synthetic. And the reason I can do it with synthetic is because I have a linear divisor. What I'm dividing by does not have exponents on the x bigger than 1. So here's how we want to set them up. The first thing to do is set the divisor equal to 0. Solve. So for this one, we're going to take x minus 3, set it equal to 0, and get x by itself. Should be a quick, easy solve. That's not a big deal. X equals 3. We know x equals 3 there. All right. Make yourself a nice little L bracket here. Big enough to write a couple of lines in it. All right. I put a little shelf right there. Not every book does that. Not every example you'll ever see. If you YouTube this and find somebody else's video, they may not put that shelf there. I like that shelf because it gives me a place to put something. The number that I'm going to put on the shelf came from this. So I'm going to put 3 up there on that shelf. Okay. When you set that divisor equal to 0, that gets you your shelf number. That's the way I always refer to that. What number goes on the shelf? Okay, so in this case, 3 goes on the shelf. Then you're going to put the coefficients, that means the numbers in front of the variables, from the polynomial we're dividing into, the dividend, on the top line here. So we've got a 2 for x cubed. We've got a 0 for x squared. We've got a negative 19 for plain x, and a positive 8 for the constant term, the term that has no variable. Okay. Again, that 0 is coming from, we got to have a representative from every power that's smaller. Okay. Now here's where synthetic division gets a little easier. Synthetic division does not involve subtraction. It's all addition. Okay. All addition with synthetic division. Makes it easier. Addition's easier than subtraction, right? Because you don't have to deal with double negatives. The first step is drop that first number down. 2 drops down to the bottom. Then, just like regular division, you're going to multiply. So it's 2 times the number on the shelf. So this number that drops down times the number on the shelf, and that's 6. Okay. Then we're going to add 0 plus 6, 6. Multiply again. This number, the 6 that came from 0 plus 6, 6 times 3 is 18. Goes there. Then we add negative 19 plus 18. Negative 1. Drop it down. Negative 1 times 3. Negative 3. We add those. 8 plus negative 3 is 5. This piece right there, that is your remainder. Okay. That number is your remainder. These are the coefficients of the quotient. Anytime you use synthetic division, it takes the highest power of the exponent, the highest exponent. We started with x to the what power? The highest one on our dividend. Third power. We did synthetic division, and it reduces the power by 1. So this will be 2x squared. This will be 6x minus 1. We have 2x squared plus 6x minus 1 plus 5 over x minus 3. There is our synthetic division answer. It always takes the power down by 1. So if you start with an x to the 4th power, if you do synthetic division, the quotient is going to start with x cubed. And you just go x cubed, x squared, and then go from there. That number that's here on the end is always going to be your remainder. Okay. Let's go back up here. I want to show you example A with synthetic division. We'll call it example E. Okay. What number goes on the shelf for this one? -6. Because when you set x plus 6 equal to 0 and solve it, you get -6. And then we're going to put the coefficients up here. 3, 22, 30. What happens with this 3? Drop it down. Always going to drop that first one down. 3 times -6, -18. 22 plus -18, +4, multiply, -24, add 6. This is the what? The remainder. Here's our quotient. Our quotient was 3x plus 4, and then we had 6 over x plus 6. We did that with synthetic division. What answer did we get when we did it with long division? The exact same one. Okay? Synthetic division gets you the same answer as long division if you do it correctly. Which one's quicker? Oh, synthetic division is much quicker. Okay? But it only works if you've got a linear divisor. Okay? If you got x squared or x cubed or something like that you're dividing by, you've got to use long division. Okay? So that's what the difference in those are. Let's do one more. We got time for that for a synthetic division problem. Let's say we had 18x squared minus 18x minus 10 divided by 6x minus 6. I know this part's not changing. What goes on the shelf? +1. As you move the 6 by addition and divide by 6, so it's +1. That's easy multiplication. I can do all that all day long. 18, there's a 0. That's 0, that's -10. This is the remainder. -10 is the remainder. We have 18x plus 0 plus -10 over 6x minus 6.
May I have your attention, please? Bus Duty is Miss Gladys. Your books are on sale for $75.
All right.